And today I would like to talk to you a little bit about Chapter 10. So if we can head over to the slides, I think you may have seen this, but if you remember, we were talking about how we might have a while loop in the Jack language, and we would like to begin parsing that. And I talked a little bit about how that's going to be a recursive descent algorithm. Let's go through what we mean. So we know in this class right now, the first part of Project 10, we want to emit a set of structured code that shows the hierarchy of the Jack language and whatever the program is. So let's talk about this parsing process. So if we look at what we have a sneak preview of the language, so the grammar. And essentially what our parser is going to want to do is we have a compilation engine class, and there are going to be several different compile statements that are going to understand the grammar of these particular parts of the Jack language, and it will then compile it. So the parser, consists of several compile commands. Each method implements the right-hand side of the grammar rule describing that command. So for instance, the compile while statement knows that it expects the keyword while, followed by parentheses, an expression, braces, statements, etc. So the parsing process, we're going to follow the right-hand side rule of and parse the input accordingly. If the right-hand side specifies a non-terminal rule, then we're going to to compile that. And we keep doing this recursively. So if we look at our example, the input is going to be a while loop. We have all the tokens we need. So let us assume that we are compiling this. We read while so that we know we need to call the compile while statement. So that method is being called. All right, so in compile while, here's what we do. The parser is first going to emit to our XML tag to say that we are compiling a while statement. That's going to then include the keyword tag while. Next, we go to the next token, and we see that that is a symbol. So we wrap that in a symbol to emit what that is. All right, next we see count. And so we now recognize that we are compiling an expression that's part of the right-hand side rule of our while statement. So we start operating compile expression. We emit that. We see that we have a term, so we're going to call compile term. That's kind of where we're in now. And that's going to consist of a variable name or a constant. And we've found that we see the identifier count. So we emit that, the identifier count. That's part of term. We go to the next operation. And we see a symbol, so now we know that we are done compiling term. We are back out into compiling expression because we've seen this operation. So we emit the symbol that we have seen, and then we're going to jump back into compiling a new term again because this is what the compile expression grammar says. All right, and here we see that we have an integer constant, so we emit that to our file. We get the next token. We see that this is going to be a symbol. This is fine. This completes then our compile expression. So we know we are done with this. We go back up to where we were before in the compile while statement. Excuse me. Emit the symbol. And now we keep going. We see a brace. So we're going to emit that we see a curly brace. And now we are in compile statements. And that's just going to be a loop of compiling statement over and over again. All right, compile statements. So first keyword we see is let, so we're into the compile let statement. So we say that, let statement. We have a keyword, let. We emit that. The variable name we find the identifier, count, emit that. We find the symbol, so we're going to emit the keyword equals that we expect. And now we are going to jump into compiling an expression. So compile expression. And here we go. We see expression, we have a term, the identifier, count, etc. We keep going through. We finish compiling the let statement with the semicolon, emit that. We complete compiling the let statement. We are done now compiling our statements. We are then close that. We are done. Well, now we see the final symbol. We are done compiling our while statement. And now we have completed this. So when I talked about recursively compiling, this is what I mean. We called compile while statement. And because of the grammar of that while statement, we knew to call these other compile statements, which they expect their own grammar. And so we followed both the left-hand rule and the right-hand rule going through. And this would be the code that we finally emit for a valid while statement. I will note that here. I'll note that a couple times. When you're emitting your XML files, note that the indentation is 2 spaces for every level. So just that will cause comparison failures, but you can keep track of a variable and just put 2 spaces for every single variable you have. All right, so that's a walkthrough of kind of what we are doing in this parser. So the parser is going to consist of a set of compile, whatever, the left-hand side commands, and each of those will implement the right-hand side rule of the grammar. So for instance, like I said, we just went through compiling a while statement that expects some keywords and symbols, and it's going to call other compile expression, compile statements, etc. All right, so they talk about this compile while statement. They mention eating it. I don't think you have to use eat like they're using it here, but the idea is that you are going to expect a certain symbol once you get, or token of some sort. Once you get that token, you are done with it. If it's the right type of token and it matches what you are expecting, you are done with it. You can write to the file and move on. So when the book is talking about eating a token, they are really passing it a string. And if it's the correct token, that's fine. We can advance. Otherwise, we're just going to return an error. And this is where you can have error handling and start to write compiling commands. Sorry, compile error messages. So what they're saying here is that each method is responsible for advancing and handling its own part of the input because it knows what to expect. So what we are dealing with is a look-ahead grammar. We only need to look ahead one symbol at a time for this. So we can therefore compile everything with recursive descent without backtracking. I mean, we have to don't have to look ahead and see what we're compiling, and then go back up and call the correct method. So we are implementing an LLK parser. This is the terminology used to say that. And an LLK parser means it needs to look ahead at most k tokens to determine which rule is applicable. Everything that we are doing is look ahead 1, and for most part that's fine. It's with the exception for one part, which we'll note. This is the grammar. I gave printouts of this to you. It's also available on the Moodle website, but essentially it's just going through and defining what the grammar is. I think the most important items to note are when we see the or symbol, that's either X or Y could appear. If there's just a space, that means X appears, then Y. X with a question mark would mean that X appears 0 or 1 times, and X with a asterisk means that X can appear 0 or more times. So that's the difference in asterisk and a question mark. So this is the grammar that you have a copy of. This is the complete specification of the Jack language. We have lexical elements at the top. We have a program structure, statements and expressions, and of course then they leave their own terminals. So here's the tokens. We know the symbols. Decimals are only, integer constants are only positive, ranging from 0 to 32,767. A string is a double quotation mark followed by any sequence of characters, not including a double quote or new line, followed by a second quotation mark. That can be tricky to capture when you're coding this, but you can do it. Identifier is a sequence of letters, digits, and an underscore. So it's essentially anything that we have not otherwise seen as a keyword that's not starting with a digit. So it's a digit, we know it's going to be an integer constant. So you know that a Jack program, because of Project 9, it's a collection of classes, each with its own file. Each of these are compiled separately. So in this case, each Jack file is compiled to its own, for now, XML file. In Project 11, its own VM file. And we have definitions of what a class is. It consists of the keyword class followed by the class name. We have a set of class variable declarations and a set of subroutine declarations, and each of these have their own rules that we need to then follow through and implement. Statements. We have statements. A statement can be 0 or more statement, and then that's let statement, if statement, while, do, and return, each of those with their own grammar. Expressions. They can consist of a term followed by a grouping of an operator and term, 0 more of those, but you have at least one term. And terms are things like integer constants, string constants, keywords. Ops or operators are plus minus, just some standard symbols we know, and of course some of the other keyword constants such as true and false. One note about some parsing as we get in. What we're doing in the parser design, we have a set of these compile XXX methods that compile these various grammar rules. Each of these are going to output an XML tree and advance the output. And that XML tree is showing that you understand the structure and hierarchy of the actual Jack code that your program is able to understand. When we get to expressions, it does get tricky, and this is the one point where we will violate our look ahead one token rule, and you will need to then look ahead 2 tokens, and that's going to involve some programming to kind of get a token, keep track of that, go to the next one, and then we'll know what we're doing. So for instance, if we have an identifier, so that could be a variable name, a class name, we don't really know. But depending on, we have a variable name, and then the next one could be a square brace. Well, we know that that's part of an array, and that's going to be a term. Maybe it's a dot, and that means that we are now going to be calling some subroutine name that's part of a subroutine call. Or it could just be a parenthesis, meaning we are now just calling a subroutine as well there. We don't know, and that's the one tricky part. So you can see how I've kind of boxed these in here and shown what all these could be. When we just get a variable name token, we don't know exactly what that's going to be. So to solve this, what you need to do is look ahead, save the current token, advance to the next one, figure out what it is. Are you doing term? Are you doing subroutine? Then kind of go back to where you were. And that may be another list where you have to pop or push and pop extra tokens to that you can then remove later, or just save it in a temporary location. It's kind of up to you how you want to do that. But this is the only part of the Jack grammar in which we have to look ahead 2 tokens instead of 1. So I'm going to stop this video there, and we'll continue with a little bit about the code structure on the next one. Thank you.